Hello and welcome to the channel CSAI Think Tinker Learn. Today we're doing a deep dive architectural teardown of a Redis cluster. If you have ever wondered how Redis handles billions of requests while maintaining high availability, today is the day we pull back the curtain. We'll be dissecting hash slots, gossip protocols, and the mechanics of massive scale. Please hit that like button, subscribe, and ring that bell to help the channel reach more engineers. Also, check out the companion website bitbytoken.com for foundational and advanced system design guides across software, data, AI, and ML. Let's get into it. To understand Redis cluster, we have to understand why simple approaches fail. The most basic approach um, is modulo hashing. Node index equals hash of key modulo n. This is the fatal flaw. When n changes, due to a node crash or adding a node, the formula breaks. The result? 70 to 80% of all keys are remapped instantly, causing a massive cache miss storm that brings down your database. Modular hashing doesn't scale, it collapses. The textbooks for this, the textbook's fix for this is consistent hashing. You map nodes and keys into a 32-bit circular space. When you add a node, it only displaces key from its immediate predecessor, which is a huge improvement. But why didn't Redis adopt it? Because virtual node management is complex. Data migration during resharding is mathematically imprecise, and multi-key operations break easily. Redis needed something more robust. Redis introduced a fixed intermediary hash slots. Here is the key insight. Redis doesn't map keys directly to nodes. It maps keys to slots and then slots to nodes. By decoupling the mathematical hash from the physical hardware, Redis gains precise operational control. Adding or moving a node just means reassigning a block of slots, not a massive reshuffling of keys. Why exactly 16,384 slots? It comes down to gossip protocol efficiency. 16,384 slots fit into a 2 KB bitmap. Every node in the cluster constantly gossips its view of the world to every other node. A 2 KB payload is small enough to fit into a single UDP packet and scales well to about 1000 master nodes. If they use 65,000 slots, that 8 KB payload multiplied by hundreds of nodes would waste gigabytes of cluster bandwidth on gossip traffic alone. How do we handle multi-key operations? Use the hashtag. If you have a user profile and a card and you want them on the same physical node, you wrap the user ID in curly braces. Redis hashes only the string inside those braces. Everything else is ignored, forcing related data into a single slot. This is mandatory for operations like mget or multi-key transactions. But be careful with your tags. The hot slot is a major danger zone. If you use low cardinality tags, like a status enum, you force massive amounts of data into a single slot. That one node becomes a fatal bottleneck, defeating the entire purpose of horizontal scaling. Always use high cardinality IDs, like user IDs or tenant IDs for your tagging. How does the routing work? When a client with a stale topology map hits the wrong node, the cluster moves or sends a moved redirection. This is a permanent bridge reroute telling the client, I don't own this slot anymore, it belongs here. Smart clients then issue a cluster shards command to refresh their local map, and latency returns to sub-millisecond speed. Sometimes a slot in the in-flight limbo during zero-time resharding. This is where the ask redirect comes in. Unlike moved, an ask redirect means this slot is currently moving. Check the new node for the just this one key, but do not update your local map. It's a temporary bypass for data in transition. The glue holding this together is the gossip protocol. Every node maintains a full mesh connection to every other peer. The exchange, heartbeats, slot assignments, and configuration epochs, logical blocks that prevent stale state. This is entirely decentralized. There is no single coordinator like Zookeeper. The cluster state emerges organically from peer-to-peer consensus. How does it handle faults? It goes from P fail to fail. If a node is unresponsive for 15 seconds, it is marked as potentially fail, P fail. Once a majority of master nodes agree, the state escalates to fail, and the replicas automatically starts an election. The winner promotes itself and broadcasts the new topology. Total failure time is typically around 17 seconds. Here is the hard truth about consistency. Redis prioritizes sub-millisecond latency over strict durability. Because the master returns OK before the replica acknowledges the write, any master crash in that tiny window results in a lost data. If your system requires a strict consistency, you must use the wait command to block until replicas confirm, deliberately sacrificing throughput for safety. This comparison matrix breaks down the difference between consistent hashing and Redis hash slots. Redis uses slots for explicit, precise operational control and minimal gossip bandwidth. It's an engineered choice for manageability over mathematical purity. Be aware of the hard system boundaries. Redis cluster has a scale ceiling of about 1000 master nodes. It only supports a single database. It bans cross-slot operations for mset mget, and it has weak consistency due to asynchronous replication. Understand these limitations before you commit your architecture. To wrap up, Redis cluster replaced brittle math with a fixed intermediary layer, solved multi-key routing with hashtags, wired it together with a 2 kb gossip protocol, and made it resilient with automated failover. The engineering elegance here is in its complex math. It's in combining simple, pragmatic abstraction to operate at massive scale. Now, I have a question for you. Have you ever hit the hot slot bottleneck in production environment, and how did you resolve it? Let me know in the comments. Don't forget to like, share, and subscribe, and I'll see you in the next one. Thanks for watching.